Hello and welcome to the Applied Deep Learning course 2022 at the TU Wien. My name is Alexander Pacher and I will be your instructor for this course. In this course, you're going to learn a lot about machine learning, more specifically about deep learning and how you can apply it to solve challenging tasks that just a few years ago have been considered very difficult or even not really solvable with computer methods. A few words about me. As I said, my name is Alexander Pacher and I work as a software architect at a startup in Berlin called eNote, where we try to build intelligent sheet music for musicians. I'm also a musician myself, therefore this is a nice fit for me. I'm a member of an a cappella ensemble called Roots and Roots and a member of the TU Wien choir. A few years ago, I did a PhD in the field of optical music recognition, where I tried to teach the machine how to read music scores. So going from an image of music scores through a machine learning process to something that the machine can actually understand and, for example, play back to you. During that time, I used a lot of deep learning technology and I thought it's really interesting and it's really something that's been working great for me. So I wanted to share some of the knowledge that I've gained throughout my PhD, and I created this course as a result of it. And you're probably here because you read deep learning and you went, woo! Deep learning is really cool and I want to learn about this. I want to become rich. I want to become famous. I'm gonna start my own startup and build something really cool and solve every problem that is there with deep learning. And you're definitely not alone with the sentiment. According to the Gartner Hype Cycle in 2018, when I started this lecture, deep learning and deep neural networks were at the peak of inflated expectations. So it was everywhere around and everyone tried to build something really cool with deep learning. And this trend hasn't stopped yet. It has continued in 2019 with several artificial intelligence topics being also here, like explainable AI or transfer learning. And it has continued in 2020 with, I think, around 10 technologies and topics that are also present here in 2021. So you can see there is still a really high demand for this technology and a really huge interest. And if we are at the peak of inflated expectations about deep learning, well, what comes next? The trough of disillusionment. I hope that in this course you will not end up in this, but actually will learn how to build something useful with this technology. But talking about inflated expectations, I can't help but show you this nice clip about a different technology that is also, I would say, very close to the peak of inflated expectations, or at least has been there some years ago.
Could CRISPR give us unicorns?
So, we're getting creative now. So there are examples of animals that have single horns in the middle. So like the rhinoceros has one at its nose, but there are other ancient rhinoceros that have it in the middle of the head. So anyway, I think that you could get a single horn on a horse by looking at horns in other species.
So it's in the realm of possibility.
Yes.
Well, this is a more humorous example of inflated expectations about CRISPR, the genetic chain scissors, how they're sometimes popularized, which allow you to edit the DNA and do some things that before that have not been able to be done at this scale or at this kind of ease. And I think it's quite nice because you see how people become creative and think of things that, I mean, theoretically might be possible, but in reality are still far away. And this is something that we can also see with deep learning nowadays, that sometimes people think, oh, this is going to be really bad, this is going to take over the world, artificial intelligence. And then when you start actually training your first neural network, well, the reality sometimes looks a bit different. So what is the goal of this lecture? First of all, I would like you to understand what can and what cannot be done with deep learning to exactly avoid this pitfall of saying, well, let's just solve everything with deep learning, because it has certain use cases where it's really powerful and has brought significant advances to research in general and to specific fields like self-driving cars, but it's not applicable to every single problem. There are just things that are too complicated to be solved even with deep learning. I want you to gain hands-on experience on how to pull off a deep learning project, how to build such a system, how to train models, how to select them, how to evaluate their performance. And in my opinion, the best way to do it is by just doing it. So this is kind of at the core of this course. And last but not least, I want you to not only be able to build such a system, but also to reflect upon it and understand, is it good, and how you can present it to someone in a way that they understand what you're currently able to achieve with it. A few words about this lecture. It's called Applied Deep Learning, and the key here is applied. So I want you to be actually doing most of the work in this course. And how will you be doing this? By doing a project. This project is at the core of this course, and I will try my best to give you some theory that helps you to work through this project in these weekly lectures like this one here. There will be 3 assignments that should help you to kind of guide you through that project that you will have to hand in, such that I can see what progress you're doing and to help you. And at the end of this course, you will submit a written report and present the overall achieved results from your project in classroom here with all your fellow students. The project itself is up to you mostly. So I want you to pick a topic and pick a project type. So the topic that you will be choosing for your applied deep learning project should be something that is interesting to you, that you want to be working on, that motivates you, and that is at the same time challenging and useful for you. So I want something that you think, oh, this would be a nice idea. I want to give it a shot. I want to try it to see how far I can get with deep learning. The project types, there are 4 types that I've kind of come up to help you a little bit understand where you're going with this project. The first project type would be called Bring Your Own Data, because one of the fundamental things about deep learning is that even with a fantastic model, you will only get so far if you have insufficient data. So data is definitely very important here, and bringing your own data and your own data set and using an existing approach on that data set is also a very valuable experience on itself. The second project type that you can choose from is Bring Your Own Method, whereby you select a data set that is already existing and has been published, maybe by someone else before you, and you try your own method. You try some neural networks that maybe have been working on other fields or that you want to tweak a little bit and see if you can get better results than someone else, maybe on this existing data set. The third one would be Beat the Classics, where it's up to you to implement a deep learning method for something that has not really been done in this way before with deep learning, and try to see if you can beat a baseline that is established with a non-deep learning method. For example, you can say, I want to do line detection, and there are several methods without machine learning and deep learning that allow you to detect lines in images. But you can say, okay, I want to see if I can build an AI model that is actually better at detecting lines. And the last of those 4 topics that you can choose from is going to be the most challenging one, and it's called Beat the Stars. So in this project type, you will try to find a project, to find a topic and a problem that you will be working on, and you have to do some research to understand what is the state of the art here, at least the state of the art when you start the project, and try to improve that. This project type I only recommend to PhD students that are sometimes or most of the time already working on similar topics for their PhD. So the goal would be to take this topic and improve state of the art there. And ideally, if you are able to do it, you can publish a paper at the end. How does grading work for you? The project is, as I said, the core of this course, and you will be continuously graded. So the type of this lecture is immanent, and you have 5 parts that I will grade separately. The first ones are the assignments with 10 points each, and in the end, the report that you hand in, the written one, as well as the presentation that you give in class, will also be awarded up to 10 points each. The criteria for all of these are obviously the results, whereby I want to mention that failure is acceptable. If you try a really complicated, if you're working on a really complicated problem and you're doing your best and you try to beat the stars, but you're only able to improve it maybe in some situations, you might say, okay, but you haven't improved the state of the art, but you've still learned a lot, hopefully, and tried several things. So failure is acceptable, but if you fail, I want you to fail smart and understand what has gone wrong and why it has gone wrong. Other criteria that I'm going to apply to your submissions is creativity, complexity, and given that we're studying computer science here, also code quality and the way how you present the code, how you present the documentation to make me understand your code, as well, of course, for the presentation in the end, how you're going to present it to your colleagues. I think the code quality is really important because you will have to understand your own code. I will have to understand it when I'm reading and grading it. And ideally, you build something that you might want to use in the future. So it's also for you very beneficial if you are able to understand the code by just reading it again if you come back, say, half a year later. The grades are according to this general scale, so I think you can read it on your own or come back here for reference at a later point. Let's come to the assignments and let me explain them a little bit in more detail. The first assignment that you will be working on is called Initiate. In this part of your project, you will come up with a topic. You will try to figure out, is it something that can be done with deep learning? Is there some existing research, maybe some existing models, data sets? Gather data and try to understand how will you be moving forward from here. Create a plan, understand what you will be doing when. The second assignment will be the actual hands-on experience where you will be training a neural model, trying to improve it, try to optimize as much as you can within a given time frame. Because this course takes place for just one semester, so you only have a certain amount of time to optimize your models and play around with them. So try to do as much as you can and then kind of finish with whatever trained model you come up with in the end. And then you should move on to the third assignment, which is called Deliver, where I'm basically your client, and you can imagine that I gave you this task, whatever project you chose from, and challenge you to bring me something that I can work with. So I would like you to build a small application to actually run the model that you've trained in the course. So you will be providing deliverables, maybe a small web application, something that I can actually play around with and that you can demonstrate also to your fellow students and, ship it. A few words about logistics of this course. The entire course will be held online and there will be weekly lectures that should cover topics that are relevant for your project, where I will be trying to do my best to cover as many topics as I possibly can, because also your topics can be of a wide variety of ideas. And I will try to post them as soon as possible, such that you can pick which lectures you choose. And I would strongly advise you to watch them on a weekly basis, because we will have weekly Zoom calls where we'll have like Q&A sessions, which will allow you to kind of, if you don't understand something, ask questions about a specific lecture. Of course, you can always ask me also questions about other lectures, but I would like to kind of focus on these weekly calls on specific lectures. And I will be also posting Slido sessions for each lecture, such that you can post questions anonymously if you wish so. The final presentations from your side for assignment number 3 will also be online, and it will be a 5-minute video that you will record upfront, upload, and then we will watch it together in the last 2 lectures of this course. And then after each video, we will have a short Q&A session that allows also your fellow students to ask some questions about your projects. The entire course is limited to a maximum number of 25 participants, and this is mainly because I'm limited by the amount of feedback that I can provide to you and the time that I have for this, because I'm also having a full-time job. So I want to read through every assignment and read your code and try the models and give you individual feedback. And if I have more than 25 students, this becomes really hard for me. So potentially there will be more than 25 students who want to participate, in which case you can either just watch the videos online, or you can participate, or you'll have to participate next year if you want to receive a certificate. At this point in time, I would also like to say that you should please only sign up for this course if you are willing to actually finish it and if you have the resources. This course will require a lot of development efforts from you, and in the past 75 to 100 hours of work has been kind of the average from the students, which means that the ECTS are kind of, I would say, correct for this course, maybe a little bit more, depending on how much you want to work on your project. Obviously, you can also do a simpler project in which you will maybe land on the lower scale here. So there, at least for the last couple of years, there have always been some students that started the project and then unenrolled in the middle. So ideally, I wish that you only sign up for this course if you're really willing to complete it and you have the resources to do so. For me, it's also a matter of fairness to your fellow colleagues that want to take the course, but then maybe can't participate because we only have 25 seats. And then if you drop out in the middle, they would have maybe sticked around till the end. So ideally, 25 students start, and in the end I hand out 25 certificates. That would be ideally. I also want to say a few words about the Deep Learning for Visual Computing course that is also offered at Technical University in the summer semester, if I'm not mistaken. This course is listed as a preceding course, as an optionally preceding course, because there are many things that are overlapping between them. However, the structure between the two of them are fundamentally different. So while in the Deep Learning for Visual Computing you will dive into a project as well, it is from the visual domain. So you will build an image classifier, you will try to train around this, and you will gain a lot of theory about backpropagation and other topics that I simply do not have the time to cover in such great depth in this lecture. So applied deep learning covers a broader field, but not in such depth. So I will try to also cover other fields and other technologies, especially some recent developments like transformers and graph neural networks that I included in this lecture because I think they're very interesting to learn about. But obviously, if you only have one lecture time, the amount and the depth you can cover is not as deep. I personally recommend that you also take the Deep Learning for Visual Computing class. It's an excellent class, and you can also do it as a continuation class after this one if you want to go into more depth about some of these aspects. A few words about the project that you will be doing. I would like you to do the project alone. So each and every student will work on their own project. You should discuss the issues you encounter with your colleagues. However, I have the feeling that the best learning experience can be done if you actually do it on your own, fail, try to understand why it's not working, and then build something that you really understand and build on yourself. The Tool course will also be open for questions. Please post questions and try to help your peers there as well. Otherwise, you can also write me an email and I will try to reply to you. Of course, the weekly lecture, the weekly Q&A sessions is also an ideal spot to raise questions if you have them regarding not just the lecture itself, but also maybe your project. This is something that I would also like to warn you. You will have to train some neural networks here, and these are computationally intense to do, and you will have to bring your own computing resources. I am not able to provide you some servers for training so. However, most of, I would say, modern computers with graphics cards have already the capacity to train machine learning models at a good speed. So if you have a desktop computer that has a graphics card that is CUDA enabled, there is a good chance that you are able to just train these models on your own. If you don't have that, there are also some online resources that I can absolutely recommend, including Google Colab, in which I will be showing most of my demos as well. And there you can train on some external servers, and it's basically a Python Jupyter notebook. You can run your models, you can train them even on GPUs and TPUs, and it's really nice. You can use it for free, and this is definitely a viable option for many of you if you do not have a powerful graphics card in your computer. There are also some other providers that I want to mention here. So pick the one that feels best to you and whatever like your requirements are, and there you will be able to train your project on. Finally, I want to briefly summarize the schedule for the semester. So I'll be covering these topics that you can see here, and the idea is that on each of these dates we will be having a Zoom call. The specific times are listed in TIS, but basically it's Thursday 4 p.m. in the afternoon. And I will be trying to upload the videos much more in advance to give you some time to watch them. I recommend that you watch one video at a time, because also to give your brain some time to process them. But you can feel free to maybe skip ahead or do some other videos first if they maybe feel more fitting to your project. For example, if you want to work with recurrent neural networks, and then you can kind of take that video and watch it first. You might need to come back to the other videos to understand some aspects, but this I'm trying to, or at least I hope, will give you a bit more flexibility on how you want to structure your own learning process. There are also some quizzes on Tuwell that I created to help you understand and kind of recapitulate on the things we've learned in these lectures. There are 3 important deadlines for you to remember. One is in the end of October for the first assignment, where you will be handing in your project proposal. Then one before Christmas, which should signal the ending of your hacking kind of assignment, where you have the model. And then the end of January, before the 2 presentation slots that we have here, you should hand in the final application that you've built for assignment 3, the report and the presentation, and you will then be presenting those in Classroom. That should cover all of what I wanted to say here from the logistics side of the lecture. I hope that you will have a great lecture. I'm hoping to see many of you in Classroom, and have a great day.